Alright, August the 6th. Alright, yesterday was terrible. 3 hours.
Alright.
And wasn't able to solve it. So, actually, after that, I did a top-down. And it worked. So I'm going to do it one more time. Okay? One more time. I'm going to do top-down. So, I did it, but I deleted it. So, I'm going to do it one more time. Just
I
to...
never had ice cream yesterday.
We never had ice cream yesterday. That was terrible. We should have ice cream. Alright, let's do this. Search a 2D matrix. I've done this before, many times. I'm not sure many times, but I think at least twice. Mn. Each row is sorted non-decreasing. And the first integer of each row is greater than the last integer of the previous row. So you're telling me it's sorted each column as well, right? Is that what it means? Each row is sorted, non-decreasing. The first integer of each row. Oh, only the first integer. These don't really matter. So only the first integer of each row is greater than the integer of the previous row. Given the integer target, return true if it is a matrix, false otherwise. So it's basically binary search. Yeah, you binary search the first column, right, to know which row it should be, and then actually I'm not. All it says is the first integer of each row is greater than the is greater than the last integer of the previous row. And then yeah. So you binary search on the first column to know which row it should be, and then you binary search the row. 2 rounds.
Haven't found the ball.
That's wonderful. Alright, I just realized what we can do. Let's Java this thing.
No.
Oh my god. Huh. I haven't set it up yet. Oh my god. How do I do this? So I need to create a new project, I think. How do I create a new project? New project. New project. We'll call it LeetCode. Java. Oh man, but do I? Okay, how about this? We'll do it here, right? And then we'll copy and paste onto the, because I don't have the git here. Or can I? Nah, I kind of don't want to make. Oh, that's a decision I need to make. How do I incorporate Java into this? How about, yeah, we code it here and then we copy. Yeah, I want to keep one repo, so I don't want to do it here. One repo, that means we don't need a new project. All I need to do is, yeah, maybe I should have a new project. A new project. Okay, let's do a new project. Right, let's do this. But no. Would you like to open the, yes, new window? Wait, hold on, new window. What about the other one? Oh. Huh. That's how I organize, huh? Okay. What do I need? I need to build this. Build to run, and I don't like to. Yeah, I'll just keep it at the bottom. That's fine. I'll keep it at the bottom. Then what? No, I don't need to onboard anymore. So I need to change this into Java. So that's a class, right? What I do with this class? Can I have another class inside here? I'm not sure. Still very green with Java. Okay, so I'm thinking maybe I can do this. Yes, and then here I can do my test case. Right, here I can do my test case. I can say solution sol equals to, now you assign new solution, all right? And then tests. You know what? Let's deal with the tests later. I deal with the tests later. Can I just have? Can I move this by itself? Yes, that's what I want. And I don't want a full screen for this one. I don't want a full screen for this one. Let's get this. So this is whatever it is. This is going to be for. There we go. Okay, so now that's code. Binary search. What's binary search in Java? I know they have a binary search. Let's see. Java binary search. I don't need algorithm. I just want here array.binary search. Wait, if it doesn't exist, what did it return? Nah, I don't need this. Doesn't find the element. I want to bisect find, like find. Otherwise, insertion point minus. The insertion point is defined as the point at which the key will be inserted into the array. The index of the first element in the range greater than the key, or to index and index if all elements term value will be larger than 0 if and only if. This is Java's way, so it does this. If not found output will be equal to the value. This is the insertion point. Minus insertion point. So you can use this to know the insertion point. But I don't like it. Example, 0. The insertion point is 0, so the return is -1. So I just do, because that's minus is -1. So I just need to do +1 and then take. I see, because they want to. I mean, I don't really. I won't say I don't really care. -1, 12. Insertion point will be 0, 1, 2, 3, 4, 5, 6. So it come out as -7. I see. But if you define a start and ending index, I see. Okay, so I need to get the column out first, right? Now I can say int first column equal to int. Wait, I need to say m equal to matrix dot length, int n equal to matrix 0 dot length. All right, do I always have a matrix, right? 1, yeah, okay. So I have these two, I have m and n, and then first column is int. How do I how do I initialize? I guess I don't initialize. I create a thing with length m. Actually, is this syntax even correct? Hold on. Int local variable. I don't want local variable. Wait, hold on. How do I define the array? No, I don't want this. I want to define an array. Java array. No, I don't want that. I have no idea.
Find new, right?
Yeah.
New. You have to use the word new.
Yeah, but that's the reference class. I was trying to do the non-reference. Oh, I can just do int, but then I cannot add new things to it, right? Oh, no, you're right. This is new as well. My bad. It has to be new. New int. There you go. Thank you very much. Okay, so that's that. Now I need to fill this one. How do I fill? We say for int I equal to 0, I smaller than m, I plus plus, right? Then we do first column I equal to matrix I and a 0. Okay, so now we translate to first column. Then for the target, we say int a row index. That's actually not row index, right? That's just index. Binary search index, BS index. Binary search, bin search, row index, column index. Wait, is it a column index or row index? I call it column index. Okay. Column index equal to first column dot. Huh? It's not that. Which? Arrays. I need arrays. My bad. Arrays. Dot. Binary search. First column and target. Okay. We say if binary search this one is larger or equal to 0. Right? If it's larger or equal to 0, that means we have found it. Yeah, if it's larger or equal to 0, we already found it. Oh, I think we have to do a parentheses. Okay. If it's larger, then we return true. Right? We found it. Otherwise, we can say int. That's not binary search column, and we just say int the insertion point, right? So we shall say. Actually, that's not column. That's actually I call it. This is row. This is going to be row index, right? This is going to be row index, and we say row index shall equal to binary search this +1, and the whole thing take negative. Right. So this is the insertion point, which means this is where it's bigger. Right. This is where it's bigger. Okay. Where it's bigger. So this one is the value is bigger than current. So I need to do this -1, right? I need to do this -1. So we need to do this -1. Okay, -1. Then we can say if row index, right, is smaller than 0, which means initial is smaller than everybody. Then we return false. How? Otherwise, I have the row index. Then I can do int binary bin search column index equal to arrays dot binary search matrix row index target. Okay. Then again, this one we can just say return binary search column index is larger or equal to 0. All right, let's see. How do we test this here? So I can say tests, right? Oh, I have to define. Oh my goodness. I have to define. Dude, I don't like it. Is there a easier way to do this? Hash map. Hash map. No. Hash map. What would be a best way to test this? I mean, you cannot put them together. So matrices, target, answer. So we have to do 3 things. Okay. So we can say that's going to be int this. Matrices. We assign it to. How do we assign? How do we initialize? Hold up. Java. Initialize. What's got 2D array? 2D array. And it's actually 3D array. Do you initialize? Oh, I see. So it's gonna be this, right? Why this is so many? Shouldn't it just be 4? I don't understand. Oh, anyway. So this is the first. Man, Python is easier to use, right? You have to agree with us. Python is so much easier to use. This is going to be. This is the first test case. Hold on. Do I use a comma? I use a comma. This is the first test case. Second test case. Okay. So the first test case is going to be. I don't understand. I cannot. Oh yes, I can. There you go. Right, so first test case is gonna be a array of array as well. Then we have, this is the first row. Holy crap. This is absolutely bonkers. I do not like this. 1, 3, 5, 7. Right? Why are you not happy? And illegal initially for int. I don't know. Is this what? Is this not right? You know what? Let's do take me a while to fully understand this. Hold on. Int this matrix equal to this is the first column, first row, second row, third row, fourth row, right? And this is gonna be 1, 3, 5, 7. It's gonna be 10, 11, 16, 20. It's gonna be 23, 30, 34, 60. My bad, that's it. Okay. This is fine. But what if I want to add another level? Right? This is not right. But we can add this on top. Yeah, now you're right. And the second one is exactly the same, and this we can call it matrices, right? So it's the same thing. Okay, so we have two matrices, and int this targets equal to 3 and 13. All right, then solution is this. Answers int answers true and false. I know it's not, it's just Boolean. So I get a solution. Then we say for int I equal to 0, I smaller than, okay, so answers dot length I plus plus, right? And we say int, no, we say result, Boolean result equal to solution dot search matrix matrices I. What's this one? Target. So targets I. If res is equal to answers I, system dot out dot print line, printf what do I usually print? Test something pass. Okay, so test %d pass. %d is gonna be I, right? And else the same thing, and that's gonna be fail, fail, and we're gonna do %s fail, answer %s res %s, and answers I, and a res. I don't have the debug. Oh, I can debug in this one. Huh. All right. Why does this run? Oh, true. Okay. Let's run it. Pass, pass, but you forgot to do this. All right. Oh my goodness. Why you have underscore in Word? Typo. Can I disable the typo? Okay, let me see. This is IntelliJ, right? IntelliJ disable typo check. Settings. And I guess just go to settings. Editor. Inspection. There ain't no inspection. What the hell? Okay, inspections. Proofreading. Proofreading. Uncheck. So proofreading, uncheck. There you go. Thank you. Don't need to proofread my variable names. Alright. Do I need to copy this one as well? Yeah, I guess I copy this one as well. Let's run it here. In fact, better yet, we're gonna run a few test cases, right? 61. That should be 7. That's a good one. All right, let's give it a shot. Yep, looks good. Yeah, 2 times. No, 3 times. Did it 3 times. I'm starting from. Oh, it was Java. Oh my goodness, it was Java 4 years ago. 4 freaking years ago, it was Java, and then I'm coming back to Java. How did I write 4 years ago? Interesting. I wonder. You gotta be kidding me, man. What's this one? Binary search. Oh my god. I wrote a binary search myself. Holy crap. Did I not know there's a binary search? Not sure. Maybe I did not know. Maybe I did not know there's a binary search. Huh. Oh well. We do comments. It's this, right? Yes. LeetCode. Wait, why you have this? Dangling. Remove dangling. Oh my god. Oh, okay. Yeah, this is what I wanted. Code 74. Well, finally back at Java. Need to use it because like I went through some job posts. My god, Java is still the king. So many Java if you know Java. So I have to get back to learning Java. 2 rounds of binary search. First round. Oh, but this one, yeah, it should be fine. The first round, find which row we shall investigate. We have the lines. Yeah, it does. Shall investigate the second round. Search through the target row. Well, we have all. I didn't even use this. Dear me, didn't even use this. This one, I didn't even use this. Yeah. So we say OM as this plus log M is this plus log N. Yeah. I mean, I haven't done 0 millisecond for a while. Feel happy. Alright. So here's the deal, right? We will copy this whole thing, come to here, but we're not coding directly here. We just say no, we're gonna say st 2023 08 challenge 08 0 6? Ah, yesterday is 06. Oh, 07. Today is 07. Yeah. 07. This is gonna be .java. Right? The file is, yeah, this file main.java. No, it's not you. It's you. Right? Main.java. So I guess it's fine. So we do Java, we copy and paste this inside and save it. Done. Alright. First Java, done. Now we're gonna do this one more time. Alright, we're gonna do this one more time. Forget about the previous. We're gonna just restructure this thing. So now we go back to Python, so it'll be slightly easier. Alright, let me go back to this so we can analyze it one more time. So we're gonna do DP, right? So we have DP num, I will call it unique. DP unique songs and size, the size of the playlist. So this gives us the total ways of constructing the playlist. Okay, so this is what we have. So now what we do, we say, okay, I will put the first, okay, this is the current, I'll put this, and I want the remainder to have no repeat of this thing, no repeat. So if I do this, then this one comes to DP unique -1, right? So we come in, we have however many unique, we remove one, so with -1, and a size -1, right? Size -1. And then for each unique here, I can do this. For each unique here, I can do this. So total, we have unique number of this, well, multiply this. So that's situation 1. Situation 2, right, we're looking at here, and then we say repeat, right? We want this to repeat. If we want this to repeat, then for each one, the total number is going to be DP, because it's repeating, so this will contain the same number of unique songs. So this has to be unique, right? But the size is reduced by 1. So now the question is how many uniques we can put here. Now we're looking at K, right? Because K, so the first time this can repeat is is here. It's the first time it can repeat. And I have K songs in between, right? Which means any of these K songs cannot be here, right? Any of these K songs cannot be here. So we have basically for each, right? For each this, for each of this is hard to explain. Let's just say for each of this, right? For each of this, I have unique minus K, number of choices. For each of this, I have this number of choices. For the next, I have number of choices. I have total this multiplied by this. And that's it. That's it. Simple. Straightforward. I really have no idea why yesterday I struggled so much. So freaking much. Very angry, honestly, telling you. Very angry that I got this one wrong. So let's code it. Okay? Very simple. Very, very simple. We get a mod up, right? Then we do the def dp unique and size. We return an integer. Now here the edge case, right? The edge case. So we can say for the edge case, if unique's n, it has to be smaller or equal to. So if this is larger than size, right, then we shall return 0. It cannot be larger than size. And because what we're doing is minus, so it can be negative. So we say or unique is smaller than 0, or size is smaller than 0. Any of this will return 0. Now we say if unique is equal to size, this is what we identify. If it's equal to, then there's no repeat. So basically, we shall return math.factorial unique. Right, that's it. Otherwise, then we can do this. We can say res equal to first situation, right? Unique times dp, unique minus 1, size minus 1, mod, right? And then the second one, of course, unique has to be larger than k. And we say if unique is larger than k, then res equal to res plus unique minus k. That's the number of element that can be repeated multiplied by dp unique size minus 1 mod. Then we'll return res. And for answer, we'll return dp unique is n. Let's go. Okay. Now we try this, and it's correct. And then we copy and put it here. Run whatever this. It's wrong because I forgot the mod. I made this mistake yesterday as well. Okay. Now we submit it. Voila. Why so slow? Oh. Sorry. That was ridiculous. I forgot the cache. Should have written the cache earlier. There we go. Yeah, cache. Need to cache it. Right? I got it. Okie dokie. This is top down. Alright. Top down DP. Really not that hard. I have no clue, man. Yeah, sometimes it happens. Alright, so we turn the page. Alright, turn the page. Buy 2 chocolate. Alright, let's go back to Java. Alright, you're given an integer. Hold on, I think that's too big. Can I get it smaller? Yeah. You're given an integer array prices representing the price of various chocolates in the store. You're also given a single integer money represents the initial amount of money. You must buy exactly 2 chocolates in such a way that you still have some non-negative leftover money. You would like to minimize the sum of the prices of the 2 chocolates you buy. Return the amount of money you will have left over after buying the 2 chocolates. There is no way for you to buy 2 chocolates without ending up in debt. Return money. Note that the leftover must be non-negative. Okay, so basically you'll sort prices, right? And then you just, you go for the first 2, right? You buy exactly 2 chocolate and you want them to be as cheap as possible. Yeah, so you sort. I think I can do this, right? I copy this. Okay. I can say buy prices dot sort. No, is it Java array sort? Array dot sort. Do we get a new one or is it in place? Array dot sort in place. So we say arrays dot sort prices, right? And we say if prices 0 plus prices 1 is smaller or equal to money, return money minus prices 0 minus prices 1. Else return money. I think that's what I want. I think that's what I want. Did we get this right? Ah, screw you. I'll just copy and paste the whole thing. I think this is what I want. Yeah, this is what I want. What do we say? We say sort and then get. Actually, I don't even need to sort. All right, I can just get the smallest answer. Sort and get the first two prices. But actually, we don't even need to sort. We can simply find the two smallest. But sorting is easier. Find the smallest, the second smallest. Yeah, we can do that. You wanna try? Yeah, sure. Why not? But let's copy this one here first. So we can say st LeetCode. This is what 2706. Oh shoot. Java. Solution 1. Now we're gonna do solution 2. So this one is find the smallest and second smallest. Int min equals int second min. Okay. Now we say for int price of prices. If price is smaller than min, second min equal to min, min equal to price. Else if price is smaller than second min, second min equal to price. If it's larger, then we don't do. So we got blah 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 once we're done. So no sorting. Then we can say this is gonna be min, and this is gonna be second min. Okay, try this. It works. I think it works too. There we go. It works. Solution number 2. This is more of a practice for Java than anything. Okay, so let's do one more. Okay, let's do one more. Extract characters in a string. You're given a 0-indexed string S and a dictionary words dictionary. You have to break S into one or more overlapping substrings, such that each substring is present in dictionary. each substring is present in the dictionary. There may be some extra characters in S which are not present in any of the substring. Return the minimum number of extra characters left over if you break up S optimally. Okay, so we want to break S into one or more non-overlapping substrings such that each is present in the dictionary. Okay, so let's say we build a try out of the dictionary, right? And then we just start searching S, and every time we hit something, we try the other. Yeah, like I just search, see if there's anything in it. If we find, yeah, it is in it, then we can walk. When we find it's in it, then we search for the remaining, right? And then if it's in it, we try to find the remaining. But there's a cost, right? Because we can LeetCode. Leet and code. Yeah, in this one is Leet and S. It doesn't exist in any of them. That will break it. So I think so you start searching for each character, right? If it doesn't exist, then you just skip, right? If it doesn't exist, then you simply just skip it. If it exists, then you can keep it, right? You keep it. If it exists, you keep. If it doesn't exist, you if it doesn't exist, you cannot use it. But if it exists, you can also choose. If it exists, you can also choose to include it or not include it, right? And then at the end, once we go down to the end, you try to see how many length you have. Okay. Oh, this one using Java will be a little bit. We need a try, and might as well do the try as a try node. Okay. Oh my god. So class try node. I just need to record. What do we need to record? I need a, dear me, what do I need? I need a hash map. Hash map. Okay. Hash map. This is gonna be a string or a char. Can I do a char? Cannot be primitive. So string. String. What's the value? Value is another track. Can I recursive do it? I guess I can. This is what do we call it? Addict. Jesus. Okay. So we have this, and next we call it string. Now we should call it length. Now we should call it string. Now we should call it length. Come on, string. String. What's this? The word. Okay. Okay, so this is a try node. Now when you first build a try, how do I build a try? I can say try node root equal to a try node. A new try node. Okay, then we say for string word of dictionary and try node equal to root. Then for, can I do string letter of word? Is this allowed? Is this allowed? It's not applicable. Okay, so probably I cannot do this. So for each one, maybe we have to say int I smaller than word dot length I plus plus. Int I equal to 0. Can I say string letter equal to word I? Is this allowed? Dot get char I. Is that allowed? Oh my goodness, I don't know. How do I get a letter from a string? Get a letter from string. Get a character. Get a character by index. Char at. There we go. I. But then it says it's wrong. Type of string as a char. Now how do I turn it into a string? Character to string. Oh my goodness. Java sucks. I shouldn't say Java sucks. It's just verbose. That's all. Okay, now I have this. Now I have the letter. Okay, and I am not using Java. If speed is a consideration, then what? Then it breaks it breaks my my concentration for this. So node, or you can say node equal to no. Node dot dict dot set key. What? Wait, how do I set? I just learned it yesterday, I forgot. Set hash map value. Oh, put. Gosh, put key and value, right? So key is gonna be letter. Value, what's the value? Value shall be a new try node. So we can do a try node, new try node. Okay, and then we say node equals node dot dict. What is the return value of this? What is this put the return value of this? It returned a v, it returned a value. The previous value associated with the key, or no if there was no mapping for key. A null return can also indicate that the map previous associated. No, nah, that's not what I want. So the dictionary, I'll put letter in a new node. Then the node shall equal to this dot get letter. Right, we put the letter in, we get the node out, then we go to the next round, and then this thing, I don't need to set a separate letter because this is just not necessary. Oh shoot, I do need to, because I use it twice. Okay, so one, this is all done. Okay, when this is all done, now I say node dot word equal to word. Okay, this is wrong. Why? Wait, hold on. No, it's not wrong. I just put a. How did I do it? I don't even know how I did it. Anyway, so this is the try. So we get the try. And then what? Oh my god, this is gonna take so long. My brain is fighting two different things. And then it's a DP, right? The DP. The DP. Oh no! I don't think it has cache, right? I have to read. I have to do the memo. Oh my goodness. I have to do the memo. The DP is starting from a certain index, right? We're starting from a certain index. What's the minimum number of characters left, right? The number of minimum characters left after you go through the try. And yeah, and then for when you start from each, you try to say, okay, the first one I want to include, or the first one I don't want to include. Yeah, two options. And then you want to include, you get. You don't want to include, you get, and then return that. Okay. Oh, so we need memo. What's this memo? Memo is going to be a hash map, right? Hash map. Index, so it's going to be int. No, I cannot use int, right? No, because it has to be reference. What's int reference? Integer. Okay. What's the value? Value is also integer. So this is going to be memo equal to new hash map. So I don't have to repeat here? I guess you don't have to repeat here. Alright. Can I define a function inside? I don't know. Maybe I can. What's this function? It's be int dp integer. Oh my goodness. Index. Wait, I cannot do it here. Integer index. Wait, hold on. What do I do? Java define a function. Define a function inside a function. I have to do it outside. Okay, so I have to do it outside. So okay, let's do it here. Do I do public? Okay, I do public int dp integer index and hash map integer memo. Yeah, I have to pass it. No. You probably don't, because you do integers. This has to be integer as well. Okay, so we don't do it here. Alright, what do? We say if memo.contains key index, right? Then I return memo.get index. Okay. Otherwise, I need to feed my cat. cállate. All right, let's keep going. So this is memo, right? If not, we need to find the minimum, right? That's what we want to find. Minimum extra characters. So I can set this to a large value. So I say memo, I'll put index large value. We're gonna put, like, say 1000. Doesn't matter. I just put a large value. I put a large value as initial to initialize, right? To initialize. Okay. So now what do? Now we have to go. Oh my goodness! We have to pass one more thing. Index. We have to pass the string. Shoot. Let's pass the string at the end. String s. Okay. So now we can say for int I equal to index I smaller than s dot length I plus plus. Okay. So for each one, right? For each one, oh my goodness, I need to pass also the try. Oh, try node. Root. Okay, then we say try node equal to root. So now for each one, I can choose to option 1, right? Option 1. Hold on. This should be option 1. Option 1 should be to say hold on. Option 1, we do not include s index in any. We take this. We take s index as the extra character. Okay, we take it as the extra character. So that shall be 1, right? 1, the current extra character, plus dp index plus 1 memo as the root. Okay, option 1. And then option 2, if we can fit a substring starting from s index into one of the words in dictionary. So we have this, root, and for this, then we say if what? If node dot dict dot contains key string letter equals to character dot toString s dot char at I. So if it contains this letter, okay, then hold on. That's We start from this. If it contains this letter, then node equal to node dot dict dot get letter. Right, if that makes sense. If it contains, then we get it out. But maybe what we can do is, can we say node? And then we go up, and we go up, and we go up. And when it's not, yeah, you know what? I think this is, yeah, I like this way. I like this. So it's in, then we get the next one, right? And we'll go back up, else, if it's not in, then we break, right? If the current letter is not, remember, it's the current letter is not in it. But hold a second, is this I still available outside? No, I think this I is not available outside. Therefore, but I need this I, right? Therefore, what we need to do is use a while loop. Oh my god. Absolutely don't like this. That's fine. That's fine. We need to use a while loop. And we're trying to fit, so it has to fit. If we don't fit, then we just, we don't even bother it. A while loop. While what? While node dot dict, right, dot contains keys. I don't like it. I like, how about we do while true? Do not do while true. No, it's easier for me to write the code. While true, then we can do this. Yeah, I think I'm just gonna do index. That's fine, right? Letter this, and we do the entire thing. If this contains node, do this index plus plus. All right, and then blah blah blah. Else, then we break. Okay, so now we have the index. Now we come out, right? Now we come out. What do we do when we come out? Now when we come out, we are at a certain node, right? We're at a certain node, then we come out, then we say if node dot word. What's the default for the string? Java string default value is it empty string? No. How do I check no? Java check if no. Object is no. Easiest is equal to no. I think I just do equal to no. We can say if this is equal to no, then now we say if it's not equal to no, right? If it's not equal to no, that means we have found a word, right? We have found a word. Then we say memo dot have an update, then put memo dot put index memo dot get. We can say get or default. Do I have minimum? Then put index Oh no, I cannot do it. I just changed index. Ugh. Damn. Index. I. Okay. Then we'll put index, and then here is gonna be minimum. Yeah, how do I find minimum? Find minimum between two mass dot min. How do you do mass dot min? Mass dot min. So I need to do mass. So maybe mass dot min. So the first value is going to be no dot word dot length. No, this one is not extra. Okay, now we're just gonna be because the current round we didn't generate any extra, so just dp something, right? The second value shall be memo dot get. I already put some value in it, so it should be fine, right? It should be fine. Oh, I need to. Yeah, I think it's fine. So dot get, because I already put some value in it, so I can just get, right? Get. Get what? Index. Right? Get index. And then we'll return memo dot get index. So this, what's this? This index. So we go all the way to I, and I is not in it, right? I, because I try to say s. Oh, holy crap! That's not. It should be I smaller than s dot length. So I come out. We all do I, right? So it means at this we don't contain, right? So that doesn't contain, and then it come out. And if it's not a word, that means we don't have anything. So yeah, we don't consider. If we do, then we say it from I, right? And then memo s and root. Okay. So memo.put, and we shall say if index is equal to s dot length, right? What do we do if index equal to s dot length? Oh, hold on. This is still the first. Okay. Then if index is equal to, then it's 0, right? Then we shall say memo. We just return. Set memo dot put index. That should be 0. And return 0. Okay. Is that it? Hash map, I have memo. I think this might be it. So now what we do? Now we're gonna call dp. I think we have to call this dot dp, right? So we start from 0. We have a memo, we have s, and we have root. I think we just return this one. Not sure. Not sure at all. It works. Dict is no. Ooh, I think I should be new hash map, right? Sorry, new hash map. Now it's this one. Oh, hold on. I think this is not necessary. Ain't right. Output 5. Dude. But you know what? With this we can debug. We can debug. Oh. So this is, I need to do this, set it up. You know what? We'll do this tomorrow. Yeah, we're gonna slow down and then just, you know, deal with Java. Have to deal with Java. All right. I'll keep working on this tomorrow. All right, see you guys tomorrow.